Hello everyone, let us now discuss today's LeetCode POTD problem, alternating groups 2. So, colors are given with us and this is a circular array. Now we need to consider it as a circular array where colors of I is equal to 0 means the color at tile I is red. Colors of I is equal to 1 means the tile at I is blue. Now, the alternating group is every k contiguous tiles in the circle with alternating colors. Each tile in the group except the first and last one has different color from its left and right tiles. Return the number of alternating groups. Note that since colors represent a circle, the first and last tiles are considered to be next to each other. Now, let us see this example 0, 1, 0, 1, 0. They gave a circle where these are the indices where we got the color. At 0 we have color red, at 1 we have color blue, at 2 we have color red, at 3 we have color blue, and at 4 we have color red. Now, the alternating groups of only size 3, we need required only size 3 are 0, 1, 2 is an alternating group, 1, 2, 3 is an alternating group, 2, 3, 4 is an alternating group. Now let us see this example. How can we solve this problem? Now, I start by taking only the first element 0. Now, if I increment or if I consider this as a window where I get only one element instead of I can also take this 3, but I don't know how can I get the size or the alternating or the window is having the alternating group or not. Now I take only the first element, right? Now my count, or let us say it as my left and my right is initialized to 1. So right is initialized to 1 and left is initialized to 0. So here the count or the size of the window is still 2, but I need a size of 6. So let us go and get the size by incrementing my right. Now if I increment my right, it is 2, but every time I increment this right, I need to check whether the uh, position at R is equal to position at R minus 1. So if colors of R is equal to, if it is equal to colors of R minus 1, then I need to get the left to this R. Let us see how I can do in the next iteration. So they both are not equal. Colors at R is not equal to colors at R minus 1. Now the size is R minus L plus 1. Why? Here the index at left where left is 0 and the index at where right is 2. Now the size will be 2 minus 1, 2 minus 0 plus 1, which is 3. So if I give the indices for every element 3, 4, 5, 6. Now you got the next R as 3. So here I'll increment my R to 3. It is incremented to 3. Now if you see colors at R is equal to colors at R minus 1. Now what I need to do at this time, I will get the left to the right because all the elements or all the sequences till here are not a valid sequence, are not in alternating groups, as this and this elements are equal, so we need to get our left to the right. So my left is at here, and after this I need to increment my right. So I'm incrementing my right to 4. If you see, I'll check again if colors of R is equal to colors of R minus 1. No, they both are not equal. Now, my left is 3 and my right is 4. If you see, then I need to get the size. 4 minus 3 is 1 plus 1 is 2. So the size is just 2. Now let me increment my r, which is 5. Now they both, the r and r minus 1 are not equal. So let me consider the size. 5 minus 3 is 2 plus 1 is 3. So it is not of the size of k. Let me increment my r to 6. If you see here, I have the size as 6 minus 3 is 3 plus 1 is 4, just 4. But my k size is 6. But they got we got this as only these elements, and we also need to consider the circular array. So for that, at this index, I can at max search for k elements or k minus 1 elements, because the circular array will be only having k minus 1 elements at the last. So if you see k minus 1 elements, right? 1, 2, 3, 4, 5. Sorry. These are the elements. Now, if I write them 0, comma 1, comma 0, comma 0, comma 1. So there are 5 elements which I had pushed back, and let me write the k is equal to 6. Now this is my new array. So for that, I have initialized or appended 5 elements or k minus 1 elements into my colors array. Now my right pointer is at 6. Let me go to the next r, which is 7. If you see, colors at r is not equal to colors at r minus 1. So at this point, we can check whether my size is k or not. 7 minus 3 is 4 plus 1 5. But my k is 6. So let me go to the next element. Here the r is 7, 8, 9, 10, and then 11. So r is 8. Here they both, the current r and r minus 1 are not equal. 8 minus 3 is 5 plus 1 is 6. So my answer is incremented by 1. So my answer is incremented by 1. Now let me go to the next element, which is 9. Here r is 9, right? 9 minus 3 is 6 plus 1 is 7, which is greater than k. Do we need to consider it? Absolutely yes. We have to consider it, because if you see, at this index, I can get a group, alternating group of size 6. Let me see how. 1, 2, 3, 4, 5, 6. But what about the previous count where I have got this one? So this will be starting at here. 1, 2, 3, 4, 5, 6. This is my another alternating group. So this is how I increment my count, which is here 9. Then I go to the next element here. Here I need to increment my count to 2. Then my R is 10 now. 10 minus previous, right? We need to consider colors of R is equal to colors of R minus 1. So if I say 10 and 9 are of same color, so let me get my L to R and increment my R. So here my R is 11 and the size is just 2, so no need to consider it. So here we got the output as 2. Now let us talk about the algorithm. Here there are many solutions of the sliding window of 2 pass and also 1 pass, but here they got the count instead of the size. Instead of 2 variables, they consider only 1 variable, which gets the size of the sliding window. And the third approach is just by taking percentile of n. Instead of appending this array, they get the index where we are by I plus I percentile n. So imagine you need to get the size at 9, right? You are at 9. Now 9 percentile, the previously the size of the array is, if I remove 5 elements, 1, 2, 3, 4, 5, we got 3 and 7. If I percentile with 7, it is 2. So the index at 2 is what I got. Wait a second, sorry. Here, if you see, I am at 9. I need to take whether what is the element at 9. So previously I got only 7 elements. So I do 9 percentile 9 percentile 7, which gives me 2. So 2 at 2 I got the same element as 9. So this is how I get the index. If you want, you can write the code by yourself by taking the index I percentile n. Here the n is the previous size or the size of the colors. Now let me write the algorithm quickly. Let me initialize my L to 0 and R to 1, and my count or the size. Let me go to the while loop directly. R is less than n, but before that I need to do one thing. I need to append k minus 1 elements to colors array while r is less than n. I have two conditions, right? Colors of r is equal to colors of r minus 1. If colors of r is equal to colors of r minus 1, then I need to do something here. So here L is equal to r and then r plus plus. Else if colors of r is not equal to colors of r minus 1, then I need to do one thing, which is here I need to check r minus l plus 1. If r minus l plus 1 is greater than or is equal to k, then I need to increment my answer. But before that, let me initialize my answer to 0. So if r minus l plus 1 is greater than or is equal to k, answer will be incremented. Now after that, I need to increment my r plus plus, right? So this is how you solve this problem, right? R plus plus, and then after this iteration we'll be returning our sorry answer. But how can I change it so that I get the size instead of this r minus l plus 1? So instead of doing this, you can simply do the count is equal to 1 as the size of the current subsequence. Sorry, the sub array, continuous sub array is only 1. Now after that, r is less than n, colors of r is equal to colors of r minus 1. Instead of left is equal to right, I'll write it as count is equal to 1, and then my pointer I will be incremented. Here I will be pointing going to n. Now after that, if count is greater than or equal to k, answer will be incremented and I will also be incremented. This is how you solve this problem. If you want to get the index every time, I will go till like n plus k, right? N plus k, and my index will be n percentile, sorry, I percentile n. N will be going till n plus k, right? I percentile n. So every time here I'll check, previously it will be, for previous algorithm it will be I, and here it will be index minus 1, and here the count will be 1. Then I will be incremented. If count is greater than or equal to 0, answer will be incremented. So this is how you get the submission. So you will get the submissions of 3 approaches in the description. Go and check it. If you like this video, do share it to your friends and do subscribe to my channel. Thank you.